All right, let's talk about our closest neighbor in space, the moon. But we're not just going to rattle off a list of facts. No, we're going on a proper journey. We'll start with its wild, violent birth and follow its story all the way to its slow, quiet drift away from us. So let's dive in. So here's how we're going to break this down. First, we're going to look at the moon's relationship with us right here on Earth. Then we'll blast off and imagine what it's like on its surface, a true world of extremes. And finally, we'll zoom out and look at its incredible history and what the future holds. Okay, first up, the moon we all know. You know, the one that lights up the night sky, the one poets write about, and the one that has a very real, very powerful effect on our planet every single day. The first thing to really get is that the moon isn't just sitting there. It's our planet's active partner. I mean, its gravity is so strong, it literally reaches down and tugs on our oceans, creating the tides. And that beautiful glow it has? Yeah, that's not its own light. It's just a giant, silent mirror reflecting the sun back at us. But here's something you've probably noticed. When you look up at the full moon, that pattern of dark and light spots, the man in the moon, it's always the same, right? It never, ever turns to show us its other side. And there's a really cool, and actually pretty simple, reason for that. And here's the secret. It's a phenomenon called tidal locking. You see, over billions of years, the Earth's gravity has slowed the moon's spin down. Now, it takes the moon the exact same amount of time to rotate once as it does to circle the Earth. It's like a perfectly choreographed dance where one partner always faces the other. Okay, so we get the view from our cosmic backyard. But what if we could actually go there? What would we find if we were standing on the surface of that silent alien world? Well, first things first, let's talk scale. The moon's diameter is 3,474 kilometers. For our friends in the US, that's 2,159 miles wide. So yeah, way smaller than Earth, but still a seriously big chunk of rock. Now, to help you wrap your head around that, imagine stretching a measuring tape from one coast of the United States to the other. That's about how wide the moon is. You could theoretically drive across it. But what makes the moon truly feel like another planet is what's missing. There's no atmosphere, and that means no air to carry sound, so it is completely, utterly silent. There's no wind to kick up the dust, and no weather at all. Just stillness. And this is where it gets really mind-blowing. Because there's no wind and no rain. Those footprints left by the Apollo astronauts back in the 60s and 70s, they are still there, perfectly preserved. Just think about that. They're monuments from a brief human visit that will probably outlast anything we've ever built here on Earth. But don't go thinking it's a totally dead world. The moon actually has its own version of earthquakes called moonquakes. Sometimes they're caused by meteorites crashing into the surface, but, and get this, they can also be triggered by the constant gravitational pull from Earth. It's a reminder that our two worlds are always connected. So we've looked at its relationship to Earth and what the environment is like up there, but what about its life story? To really understand the moon, we have to go way, way back to its violent birth and then look forward to its slow departure. The leading theory for how the moon was born is just epic. It's called the giant impact hypothesis. The idea is that billions of years ago, when the Earth was just a baby, something about the size of Mars smashed right into it. The collision was so huge, it threw a massive cloud of molten rock into orbit. And over time, gravity pulled all that debris together, and voila, the moon was born. So that story starts 4.5 billion years ago. It really puts our whole human experience in perspective, doesn't it? Our historic visits to the moon were just a blink of an eye in its lifetime. And now that story is entering a new chapter as it slowly starts to leave us. And let's just pause on that blink of an eye for a second. The Apollo program. It still sounds like science fiction. In just a few short years, NASA managed 6 successful landings, and 12 human beings actually walked on the surface of another world. Just an absolutely incredible achievement. Okay, so here's the final piece of the story, the future. Every single year, the moon drifts a little farther away from us. We're talking 3.8 centimeters, or about 1.5 inches. I know it doesn't sound like much, but over millions of years, it really adds up. And here's a wild way to think about that speed. The moon is moving away from us at roughly the same rate your fingernails grow. How crazy is that? The same slow, steady process happening at your fingertips is also happening hundreds of thousands of miles away in space. So when you put it all together, our cosmic companion, the thing that was literally born from the Earth, the force that stabilizes our climate and creates our tides, is slowly saying goodbye. And that leaves us with a pretty profound question to chew on. What happens to Earth in a billion years, when its closest friend is much, much farther away? Something to think about the next time you look up at the night sky.